And all, welcome back to the series. I am just looking at the assignments that you had submitted in the yesterday's session. I got 45 students graded 100 marks, and few students still are not graded, 0 marks are there. Just for 2-3 minutes I am going to just having a glance on these notebooks. Looking at one of the student, Mr. Sai Abhinav. Is he here? Mr. Sai Abhinav? Yes or no? Is he there? Sai Abhinav. Who is that? No idea. Okay, let me check another. Pranita? Pranita? Where are you, Miss? Pranita. Splitting is done perfectly, but the score is 0. Let me check. Yeah, everybody is missing the point. I ask you to visualize the second batch of training samples. First part, first graded cell is executing well, but the second part you are failing. Second batch. Yesterday I told you to make the data loader variable which is iterable, creating data iterator on the loader variable, correct? Using ITER is the method to be called up, so that it will become data iterator will get created. Now fetch a batch of information from the data iterator by calling the next, the function next. If you call for one time, it will fetches the first batch of data. Just leave it and call for once again. Call the next method once again, so that you will get the second batch of information. It's so simple. So when you call for the next method for the second time, then that moment of time take the tensors which are written by the next method, images and the label tensors which will be written by the second batch. From that batch information visualize the contents. Okay. So I am moving on to this today's session. So first few minutes, 15-20 minutes is the topic discussion, conceptual understanding of the main core concept that is called convolution neural networks. Okay. So with the past 2 sessions I introduced you to the concept of handling a single image, how it will be represented, and converting into the tensors and applying transformations using PyTorch framework into that particular image. Started the discussion with a single image. I take you to the concept of handling a bulk of images which are well organized and processing by the suitable image folder module, and another data set which is not organized into the subfolder in different way, which is organized in a different way, which is not compatible for the image folder. So both the ways. In such cases, we supposed to define the custom datasets class, which inheriting the PyTorch dataset class. Yesterday we did that part in the last end of the session. Okay, and we have seen how the batches information will be created, and means we reached to the stage of preparing and creating the data loaders and ready for feeding the data to the neural networks. We reached up to that stage. Just keeping that knowledge aside, now let us do focus on the conceptual understanding of this convolutional neural networks. Okay, very interesting. Just listen the concept and we'll play with the exercise. So actually these neural networks are broadly categorized into 3 types. The first one is the artificial neural networks that we started the discussion in the very beginning, with which we are able to do the regression and classification task that you can perform. Hopefully that you have studied in the second year itself using the machine learning course. We done with that part. And another category is nothing but convolutional neural networks. These are useful and mainly useful for vision tasks which involves the image data. What is the meaning of these computer vision tasks are nothing but classifying the images, identifying and detecting the objects in the images, segmenting the image data. All this is the related to the vision task. The tasks related to the computer vision and image data will be handled by the concepts of the networks called convolutional neural networks, and the last another category is a recurrent neural network that we are not going to discuss now, but I am introducing it to you. These are useful for processing the sequence data, the data which is in the sequential order. It will understanding the pattern of the sequence data and will do the analysis of sequential data, or what is that? You can see the series analysis of time series prediction, weather forecasting, rain forecasting. For such information, whatever the historical information is required for those concepts. So for handling such a sequence data and doing the series analysis, recurrent neural networks were designed. Now our today's focus is on convolutional neural networks. Let's moving on to this one. The question is obviously, when you are learning a new concept, the first question should be why I need to study this, right? So what is this need of this convolution neural network? Why we need to study this? Just have a look at about we are dealing with the image data, and we are having an image which is it's a color image, nothing but the RGB channel representation, which is of the pixel size 1000 by 1000, height and width. Okay, this is I wanted to handle with whatever the knowledge I have till now with the artificial neural networks. I haven't yet started the convolution neural network. Just imagine, right? Okay, fine. In order to process this image, how many input features are required when you work with artificial neural networks? Tell me. Obviously, this image data is to be considered into the flattened and a total of how many pixels are there? 1000 by 1000 height and width pixels, and it is a color image. Obviously, 3 channel information would be there. So the total number of parameters will be 3 into 1000 into 1000, 3 million parameters, 3 million input variables, inputs in order to process this image. So when it is connected to the neural network, you need the first one 3 million inputs. With 3 million inputs, obviously it would be better to connect with at least the minimum 1000 neurons in the first hidden layer, right? So with additionally, if I am taking this 1000 neurons at the first hidden layer, now tell me what is the total number of parameters? Anybody? 3 into this value 10 power 16 million multiplied with this connections are there with the inputs to the first hidden layer connections into 10 power 3 plus additional biases 10 power 3. So a total of more than 3 billion parameters are needed if I wanted to handle this image of 1000 by 1000 color image using artificial neural networks. Can I afford this? What is the meaning I? Machine. Of course, your machine is manageable in terms of CPUs and GPUs, but the computational complexity is very high because of high dimensionality with a huge set of parameters. The problem is the high dimensionals because of huge number of parameters. So obviously more parameters are there, it is leads to the problem of computational complexity, right? And one more additional things, the problems is lack of spatial information, spatial awareness. What does it mean is, in images, when we are capturing the image data, with respect to one pixel position, we need to identify and capture how this pixel is related with the surrounding pixels also. Yes or no? Can you do that with artificial neural networks? No, it's not possible, right? That is what called the lack of spatial awareness. We cannot relate how one pixel is related to and having the relationship with other pixels in the artificial neural networks. With this lack of spatial awareness, and there is no weight sharing also. What is the meaning of weight sharing? That is happening with the convolution neural networks. We are coming to know in the next 1-2 slides only. You just wait on it. So all these are the limitations of these artificial neural networks in order to handle that image data which I am having in front of me. So obviously one and only the solution, I am going to use the convolution neural network. Okay, I decided. Right? Let's move on. What exactly is this convolution neural? Convolution. So the core concept of this convolution neural network is, look at here, applying the kernels on image data, right? That is the core concept of convolution neural network. Applying the kernels on image data is the core concept. What is this kernel? You can see that a small window is there which is sliding across the image. That kernel is a sliding window. Its responsibility is identifying and capturing the features and the patterns in the image. What it will identify and capture? What are the features? Image is having a different types of characteristics. Shades, edges, colors, likewise. All these are called the different characteristics of the image. These characteristics to be captured in a proper way. Who will take that responsibility is this sliding window which I am calling as the filter or kernel will take that responsibility. When this filter slides across this image, whenever whatever the region it is sliding on the image area, there it will capture the input features. These features will be captured. Okay, now coming to this point of, just have a look at on this one. If I pass a kernel called vertical edge detector, what I said, kernel or the filter, it will detect the features, right? So what filter I am using right now? Vertical edge detector. So its job is to highlight and identify the vertical edges. Let's try to understand in simple way I am going to give you. If you look at the resultant image of this particular input image is applied with the vertical edge detector. Can you observe here? What is the output feature map and the output result of this image you are getting? Let me explain about this vertical edge detector. This is helpful for detecting the vertical edges, meaning that it will emphasizes the changes in the pixel intensity horizontally. It's a vertical detector, but it will emphasizes the changes in horizontal direction moving from left to right. Okay, let's have a look at here. What are the values I have taken? Don't bother about the values, but listen, just observe how the values are and what its effect is. So, this portion 111 will capture light regions. This negative value is -1. I mean to say lighter region, these are the darker regions will be highlighted. The middle zeros will ignore the pixel set vertically. So when you are crossing from left to right, from lighter region to darker region, when the pixel intensity is changing, vertical boundary will get created. Can you observe here? Look at the forehead of this person image. From darker region to lighter region, you cannot get anything. Lightly, very light color, you are getting the edge. Coming from the forehead of this image, this is the lighter region to darker region when you are moving. This is the boundary which is being highlighted perfectly. This is what the effect of vertical edge detector. What I said? These are the lighter regions which will capture this left portion, this right portion captures the darker regions. When the intensity is changing from the lighter region to darker region, from left to right, that's what I said, emphasizes horizontally. It will emphasizes the boundaries when it is handling the data horizontally. That is the job of vertical edge detector. Okay, right. Get. Next, another, if I pause the horizontal edge detector, this is how I can get this image. Am I able to capture the main important features in that original image or not? With the two filters only. Now, if you look at the size of this 3 by 3 filter, how many parameters are the, how many weights I use? 3 into 3, 9. With single filter, 9 parameters. If two filter, plus 9. Only. So, this window, this short window which is called the filter is convolving or sliding on the input region with the different regions of the entire input image. So, total of 9 parameters are sufficient to get this resultant image from this original image. How beautiful it is? Okay, let's moving on. So, such a number of filters that you can use in a single layer of convolution neural networks. For example, look at here, these are the number of pixels which I used, filters which I used, like however I introduced you the vertical and the horizontal filters in the previous slide. Okay, so these filters might help you to detect different types of edges across all the entire regions of your image, both the horizontal, vertical, slant, left slant, right slant, likewise different types of edges. Okay, right. So, when this is passed, this output is passed to the next layer of, obviously it might detect more some other features from those image which is from these edges which have been detected in the previous layer. From this slant, vertical, all these edges which have been detected in the previous convolution layer, summing together, it may capture more important features such as the eyes, nose, eyebrows, likewise. The latter layers of similar kind with more number of filters might detect the phases of the images all together. From these eyes, ears and nose together, it will be able to detect the faces. Are you following? We started with a single filter and taking to layer with a multiple number of filters, layer by layer. Finally, at some level, I ended up with the concept of some classification, like, so I am able to, the model is able to assign one label like human to those images which have been identified and detected. Once the model is trained in such a way, for the next time if the model sees an image which is having the face, it is able to detect and find and classify whether the human is present in it or not. This is how the convolution neural networks will work. Is it clear? Right. Now, what exactly the meaning of convolution operation? That is our focus. Okay, we have seen. In more detail, I am going to tell you. Look at here. This is the image, sample image which I am taking. A 6 by 6 image. It's a simple 6 by 6 image. There is no channel mentioned for this one. What does it mean? It's a grayscale image in the spectrum of values 0 to 25. So, this area of the spectrum is indicating the black color and the right region of the spectrum is indicating the white color. So, these pixel values are representing the intensities of that image. Okay. I am having a simple 6 by 6 black and grayscale image with me, and I am using A kernel or the filter of size 3 by 3. What is this filter? Vertical edge detector that I introduced in the just before slide, right? When I apply, how this will be applied, let us see. So during the convolution operation, okay, once it is applied to that, then we will get what is the resultant is called feature map, which is of size 4 by 4, we will get it. 6 by 6 image convolved with a 3 by 3 filter, we will get the resultant feature map of size 4 by 4, right? Okay, how it will be done? Let us see the detailed convolution operation. This filter will superimpose on the image starting from the top left corner. Now this region, what is the input region? This region 169251374 are the region which is convolving with the filter from the input. You have to listen. If you listen carefully what I am talking, it will be easy for you to do the next exercise. The filter is convolving with the input matrix region which is specific. Okay, with this region it is convolving. So what is the meaning of convolve? Is element wise multiplication and then summing the result together. So this one is multiplied with one. This lower position right lower values are the kernel values. Top left corner what you can see is the image values, actual image region values. So these are multiplying together. This 1 multiplied with 1, added 6 multiplied with 0, added likewise vertically like this. So totally what you are getting the results, once the multiplication, element wise multiplication is done, then finally you are getting the sum of these elements. The final value will be positioned at this location of the feature map. What is the next step? Exactly. The filter will slide to the next position. Done? And giving the result, and giving the result, and giving the results. Once the valid convolution is done across all the images in the from left to right, where it will go? One step down and leftmost position. Good. So once that entire image convolution is completed, this is what you are going to get the feature map. It's very clear, right? Okay, done. Now look at here. So what is the input image I have taken? 6 by 6. Assume it as a size n by n, and the filter is of size 3 by 3, which is called f by f filter size. Now what could be the dimensions of the feature map, resultant feature map? When it is convolved, we have seen how many pixels, how it is convolving and how many values it is generating. So from this we can derive the formula which will determine the size of the output feature map when a convolution is happened with a filter with respect to an image of sizes n by n and f by f. What is the formula? N minus f plus 1 by n minus f plus 1. This is the dimensions for the output feature map. Done? Okay. I'll just stop it here. Let's move on to the exercise. You are going to do an exercise on this convolution operation. You are going to implement the same convolution operation using torch tensors. You getting? Convolution operation you are going to implement. Before going to do that, I need few minutes of your time to give a brush up on the required libraries and the operations which are needed for doing that exercise on the torch tensors. Keep open the notebook, session 3 practice notebook. Please open, all of you. Could you please confirm once done? Session 3, PSEL session 3 practice notebook. Did you open? Fine. So few torch transformations we need to discuss before going to that experimentation or the exercise. Okay, very simple for 5 minutes. So first of all, we need to import a torch library, import it and create one torch tensor of some elements, 1D torch tensor. So tensor 1 equal to torch dot tensor and specify the values 1, 2, 3, 4. Now just print the tensor 1. Yes, I am able to create a tensor. Hope all of you started this. Two basic things you need to learn from this practice notebook. This will help you to complete that exercise. Right. I created. Now I wanted to add all the elements in this tensor. Sum of elements of this tensor. Anybody? Anybody? Okay. Have you understood what I am asking? Add elements of the tensor. Torch dot sum is the method. Passing the tensor 1, you can get the result. What it will do, it will add all the elements which is passed as a tensor to that function and will give you the resultant value, sum of elements in that tensor. Okay? This is 1D tensor. Now I want, have you done this? Okay, right. Now I wanted to create 2D tensor. It's very simple topic, so I am doing in the single cell itself. Whenever required, I will go to the next one. 2D tensor I need. How can I? This is 1, okay, comma, and one more, that is 2, 3, 4, 5. We need to pass it into the list. So I created 2D tensor and I am able to calculate the sum of all elements in the 2D tensor. Even though it is a 2D tensor, when I call the torch dot sum, the tensor is flattened and the elements were added. You need to capture these points. Tensor is flattened and elements were added. So it is returning the result. Good? Fine with this? Okay, moving on to the next step. I need one more tensor. Tensor 2. Let me create torch dot tensor. I'll go in the reverse order. 4, 3, 2, 1. And one more, that is 5, 4, 3, 2. 2 tensor I have created. I wanted to do the element wise multiplication of these 2 tensors. Perform the element wise multiplication of these 2 tensors. Can you help me? Simple, na? Tensor 1 star, tensor 2 and the result. I got it. What happened? 2 tensors element wise multiplied. Do you need of this concept for convolution? So assume torch 1 is the input, second torch 2 is the filter. When you are convolving, doing the convolution operation, you need of two tensors, input matrix and the filter. Done. Now what exactly I need is, I wanted to add the sum of these elements together. That is what my exact convolution operation. What should I do? Apply the torch dot sum on this result of multiplication result. Did I get? This is what one pixel position in the feature map by the convolution operation of these two tensor. Assume tensor 1 is input, tensor 2 is filter. Understood now? Up to this part is fine. Okay. And you need two more things, that is another one is called going onwards for the next step. So I will finish off this even here itself, padding. What is the meaning of padding? Additional boundary, simply to say. For my torch tensor, this is my torch tensor, tensor 1. For tensor 1, you just display the tensor 1 first, print tensor 1. Okay? And what is the shape of the tensor also? See that? Tensor 1 dot shape 2 by 4. Done? Done? Okay? Now, coming to this one, I wanted to apply padding to this one, this tensor. So, in order to apply padding, I supposed to call the pad method, which is defined in the torch functions library. So, I am going to import torch dot nn dot functional as a variable f. Remember and listen. Torch nn dot functional is the most important module when you are working with the torch framework. This is where the module all the neural, nn stands for neural network. Neural network related functions, everything will be available from this module. If you wanted to create a layer like convolution, pooling, whatever it is, dropout, whatever the layer, or defining the activations, all these were defined in this library only. We can access all this from this library. So now what is that padding I am using right now from this library? I wanted to do the padding, padded tensor 1. So f dot pad is the method supposed to call. What are the parameters to be passed to this pad is tensor 1, for which tensor you wanted to apply that padding, and the padding order, which is a tuple with 4 directions. Across all the directions I need the padding. Okay? What padding? One line padding only. One row of padding only. So what is this 4 in order will represent is left, right, top, bottom. Changing the value you can observe the difference. So what type of padding and the mode I am using is the constant padding. Different types of paddings are there. For 2D torch tensors, the suitable is the constant padding. With the 3D, 4D, 5D, you can find out more different types of paddings like circular something. Okay? And what is the padding value? 0. Done with this. Now display that result, padded tensor. As I missed this, alias names, right? Unrecognized, constant, typo errors, constant padding. Can you see the result of this padded tensor? My tensor 1, 2, 3, 4, 2, 3, 4, 5 is surrounded by one padding with the value 0. If you change this padding value, we will get a different result. Simple. Okay. Okay. Now you look at here, change this one. I am making it as 2, meaning that left side I will get 2 borders. Can you observe the difference? So this first one indicates the left, second is the right, the third one is the top, and fourth one is the bottom. Padding equal to 1, generally we will do the even paddings, not uneven paddings. Okay, done with the padding. So we learned the padding which is required. We calculated, we did the element wise multiplication and summing of all the elements in the torch tensor. And one more point is, if I want the maximum, so torch dot max is the method supposed to call to get the maximum value from the tensor. This you need for the max pooling layer. For average, dot mean. Done. Okay. This is sufficient knowledge for working with the torch tensors. Right. Now I am releasing an exercise, PSEL CNN assignment 4. PSEL CNN assignment 4 is released successfully. Are you able to fetch that? PSEL CNN assignment 4. Could you please confirm someone? Yes, thank you. This is the assignment asked to perform, implement the convolution operation with the torch tensors. Implement the convolution operation with the torch tensors is the task. It is clearly given. Whatever we discussed in the session, same is. Given n by n image and f by f filter, you are supposed to find the feature map by convolving this filter with that image. We know very well what is the dimensions of the output feature map, n minus f plus 1 that we discussed by n minus f plus 1. So here itself, for your convenience, clearly it is given, the convolution operation. I mean to say, concept was illustrated. So everyone has to submit. As of now, only 135 logins. Anybody is not yet logged in? Do it immediately. Just have a look on the beneath cell from the graded cell given. You can understand clear. I gave you one image input matrix which is a 5 by 5 tensor. Passing this input matrix and the kernel 3 by 3 kernel, your function, what is the name called, convolution 2D core, should return the output feature map of the dimension n minus f plus 1 by n minus f plus 1. Very simple. So the steps for implementing that also is given to you. Just have a look on those steps, it are very clear. I will make it more visible. Okay. The first thing is you need to get the dimensions of both the input matrix and kernel. The input parameters are input matrix and the second is the kernel. Matrix is there with you and kernel matrix is also there with you. From the matrices you need to get the dimensions. What is the meaning of dimensions? What is the meaning of getting dimensions? Ma? Sorry? Correct. N and F. What is this n by n and f by f? Exactly. Heights and the width of images and also the kernels. Once you get these dimensions of the image and kernel, using the formula which I discussed and listed in the problem statement, you can get the dimensions for your output feature map, output matrix. That is the second step. Calculate the dimensions of the output matrix. Once you calculate the dimensions of the output matrix, first it is to be initialized with the zeros because we haven't yet calculated. We are going to calculate the values for this output matrix. In order to get the values for that output matrix, whose dimensions which we derived just now, we are supposed to perform the convolution operation. Okay? How to perform the convolution operation? Again, have a look on this image which is provided to you. Very clearly you are getting an idea. Remember, the filter all the time will convolve across this, slides across the entire spatial dimensions of the image, starting from top left to bottom right. When it is convolving, every time the convolving region of the input is varying. So first of all, we need to capture that convolving region. Once you get the convolving region, it will be easy for you. Multiply that region of the input matrix with this kernel. You will get that particular position of feature map element. What could be the size of the convolving region every time? Ma? Sorry? Yes, what is this 3 by 3? How we are getting that? This convolving region every time it is changing, that you are getting from the input image. Who will decide that convolving region dimension? Filter. No. Filter will decide. Filter is sliding across the image. On the entire 6 by 6 image, from the example which we have taken, now the convolving region at that particular moment of time is 3 by 3. Who is deciding this 3 by 3? 3 by 3 is the filter. Any submissions are there from this exercise? Hope you are able to understand the logic. We'll see for some more time. This picture is giving you the clear idea of your logic. Looking at this image, if anybody is not able to understand, look at the image, slide and listen. At this particular position, when this yellow color is the filter, 3 by 3 filter, convolving with this region. The highlighted green dotted line is the region from the input matrix. So when the convolution operation is happening, every time the convolution region of the input matrix will get varied. But all the time size of this region would be kernel size only, 3 by 3 only. Capturing that region is nothing but your tensor 1. Tensor 2 already we are having, that is the kernel. So tensor 1 elements you need to capture repeatedly. From where? From the input matrix only. For performing the convolution, we need two things. One is the kernel, second is the input matrix, region of the input matrix. What are the boundaries of that region? Where you can get? Okay, somebody already submitted. I got 6 gradings, 28 gradings out of 34 submissions, good number. Understand the concept and apply the logic. Any errors for anybody? 5 more minutes for this assignment. Here are 141 members, but only 61 submissions. I can help you if you are struggling anywhere, but you have to do on yourself. Do not copy from others. Just follow the steps and think logically, you will get an idea. Hopefully you have completed the first 3 steps, right? Successfully. If anybody is struggling, for them I am guiding. Hopefully you have completed the first 3 steps, getting the dimensions of the input matrix and getting the dimensions of the kernel and determining the dimensions of the output feature map. Just using the formula n minus f plus 1. Once done, I told you to initialize with 0. In order to initialize with zeros, what's supposed to be used with the torch tensors? Yes, torch dot zeros. Passing the dimensions of the output feature map which you determine, you will get the output feature map initialized with the value zeros. Once done with this, you are reaching to the core concept of convolution, where we are doing the element wise multiplication of kernel over each region of the input image. So, from the input image for the first time, this will be the region, correct? 3 by 3 region 169251374. 374. For the next operation 6910 518 749. Likewise, at some moment of time, this is the region. So, what you need to capture? The convolving region of the input matrix, which is iterating, to be captured. There you will get the tensor 1. Already you have the tensor 2 in the name kernel. Multiply this kernel with that tensor 1 that you are getting called region and apply the torch dot sum. $57, good. What about the rest of the 100 members? Even we know the concepts, but we are not perfect at coding. If you want to be perfect, do practice. I need at least 100 members to be submitted. Do it fast. 81, okay, I am reaching. Let's start the countdown. Let it finish off fast. We will go to the next one. So, we are done with this part. So, we discussed the concept of convolution operation with grayscale image, right? If you are performing the convolution operation with a color image, a 3 channel red, green, blue channel image, how it will be done? So, how the image is represented as a 3 channel 6 by 6 image which is stacked across red, green and blue channels, the same way filter is also supposed to be taken. 3 channel filter. So, that is the reason why we are mentioning is 3 by 3 by 3. These 3 and thus 3 are matching together. This is nothing but the channel representation of the image. Colored images. Okay. If it is this color image multiplied with a channel, I mean it is a filter, 3 by 3 filter. Now tell me what could be the dimension of the feature map? 4 by 4 by 4. 3. 3. Anyone? Tell me. Will you support or oppose? Getting my point? Color image. 3 by 3 by 3, sorry, 6 by 6 by 6 is the color image, and convolved 3 by 3 by 3. Those 3, last 3 is the channel representation because it is color. Why it is? Right. So generally we should expect the dimension is 4 by 4 by 3. No, it is not 3. 4 by 4 by 1. You applied only one filter. Just recollect how the convolution will happen. What will happen with this is, this first channel of this filter convolved with the red channel of this image. Second channel of the filter convolved with the green channel of the image. Third channel of the filter convolved with the blue channel of the image. Every time with the convolution you will get 1 1 1 element. As a combination, these 3 will be added. I'll show you, I can illustrate so that you will get the feature map of dimension 4 by 4 by 1. If you understand this, it is easy for you to build a convolution neural networks. Look at here, this image will give you a clear illustration how the convolution is happening. What I said just now, first channel of the kernel multiplied with red channel of image, second channel of kernel multiplied with green channel of image, third channel of kernel multiplied with the blue channel of image. You are getting the pixel values which are added together plus plus with the additional bias. This is the pixel value that you are getting in the feature map. Clear? Done. If I wanted to apply multiple filters, I have shown you applying single filter even on the color image. So you got the feature map 4 by 4 by 1. If I apply multiple n number of filters, because I wanted to detect horizontal edges, vertical edges, from left to right, right to left, top to bottom, bottom to top, all these things, slant and. So number of filters I wanted to apply. Just have a look on this one. 6 by 6 by 3 is the color image which is been convolved with 2 filters, filters 1 and filter 2. With each filter you will get one feature map of dimension 4 by 4, 4 by 4. Now what will be the result? Any guessings? Stack of these outputs. So that you will get 4 by 4 by 2 now. 4 by 4 is your dimension, output feature map dimension. What is that 2? Channel depth, which is nothing but the number of kernels that you performed on the convolution layer. How many kernels you used? 2 kernels, each of size 3 by 3. Is it clear? So when you call the conv 2D layer even in the TensorFlow or the Torch, from the output by listing the number of filters, 32 or 24 or 16, whatever is the number, output feature map dimension, when you are mentioning the dimensions of the output feature map, what it is returning is the last one is number of filters that you used. That's called channel information. This channel information is different from the image channel information that we are mentioning till now. Number of filters that you are up. Is it clear up to this point? Good. Now tell me, there's a question for you. In the very first slide, I gave you one image, Modi ji image, 1000 by 1000 pixels. I told you how many parameters it is taking for me if I process that image with respect to using ANN, artificial neural networks, with a single hidden layer of 1000 neurons. More than 3 billion parameters. Now just think about this one. Assume I am using only single convolution layer with 32 filters, each of size 3 by 3, and it is a color. So what is this convolution operation it is doing happening in the CNN networks? When it is convolving the chunks of the input. And whatever the dimension of the filter that I am mentioning 3 by 3, those are the number of parameters only I am using. 9 parameters. Only these 9 parameter weights are sharing across the different spatial regions of the image. That is what called weight sharing. Those 9 parameters only we are using. We are not using different parameters to do the multiplications. That is called weight sharing. Understood now? Okay. Now, so the number of parameters with the single layer CNN of that 32 filters if I am using, so how many parameters I would get? Filter width and height multiplied, number of channels multiplied with the number of filters plus additional biases. How many filters you use? Those number of biases. Tell me what is the count? 3 into 3 into number of channels. Sorry, 3 color image, 3 and the number of filters, 32 plus biases, that's it. Just imagine, got surprised? For the 1000 by 1000 image by using single layer, only single layer, there also we discussed a single layer. There we need a more than 3 billion parameters. Here is 836 parameters. You understood what is the benefit of this convolution neural network? Now, let's moving on to the just whatever we have seen in the padding. What is the need of padding? Why I need to do the padding? Why I need to give the additional boundary to my image, like drawing the borders to the image? Isn't it the same? Drawing borders to the image. Why I need to do so? Let us understand with this. When I am convolving the 6 by 6 image with the 3 by 3 filter, what is happening? Just have a look on it. When it is started convolution, first position, this is second time, going onwards, these are the pixel regions of the input where there is very less exploration to the convolution. Correct? Only one time those pixels are going to be explored to the convolution operation. Compared to these intermediate pixels which are going to be explored for many times. If I am doing focus, very less focus on you, can I get more information about you? I can't. So what is the meaning? Intermediate centered pixels are given more priority, corner pixels are ignored. It's not meaning of exactly ignoring, getting very less, I'm losing some information. Capturing very important, if at all any important information is there at the corner, I'm going to lose it. What I supposed to do? Right. If I add additional boundary to this one, this is what padding is happening. Now it will be easy for me when I am convolving across. So for the 6 by 6 image, if we add one padding, I'll get my image, modified image size is 8 by 8. Remember, now you are going to do one more exercise. Right? On this 8 by 8 image, if you apply the kernel of 3 by 3, what you are getting the output feature map? 6 by 6, which is exactly the same as the input shape. So it is giving, you are not going to lose any information even at the corner position. Let's try to see this with this. So it is retaining the input shape. Can you look at how it is happening? This corner pixel position 60, how many times now it is going to be explored by this convolution operation? Look at here, observe and tell me. 4 times. Earlier without padding, only for 1 time. Is it clear? Now I am studying that page of the notebook for 4 times. Reading the page for 1 time is different from reading the page for 4 times. This is the benefit of padding. So there are 2 different types of paddings are there. We can call it as, one is the valid convolution and same convolution. The convolution without padding is called the valid convolution. Once with the padding if you did, then it is called same. So with padding if you did, padding equal to 1, padding value you can change. But you cannot choose the n number of values for padding. What is the problem also? There is a formula to be there to calculate how much is the padding value to be decided. You can't take padding equal to 3, meaning that you cannot draw the multiple boundaries on the image itself. Unnecessarily you are getting the noisy of data when you are processing the image. So the padding value is also very accurately you are going to calculate, right? So if padding equal to 1 is applied, then that convolution operation will give you the output feature map of size which is equivalent to the input feature map. That's why this is called same padding. Other is a valid padding. Convolution without padding is the valid padding, right? Another one is striding. What is the meaning is striding? When you are doing the convolution operation, how you are sliding across the input image. How you are sliding your filter across the image. One position at a time from left to right and top to bottom. Can't you go a little bit speed? 2 positions at a time. That is what called striding. Okay? There are certain benefits. Sometimes you need to move a little bit fast. You need to walk a little bit faster. Sometimes you need to go it slowly. It depends on how efficiently your model is capturing the images. Accordingly, you have to define this as striding. Let us do this striding, how it is happening. This is the normal striding when you choose the value equal to 1. If I choose the value equal to 2, stride, it is shifting 2 positions, both vertically and horizontally. Understood? When you are performing the convolution along with the striding, then it is called strided convolution. Look at here. Are you not able to catch it here? How many positions it is sliding compared to this one? Stride equal to 2 is mentioned, meaning 2 positions it is jumping. This is what? Strided convolution with padding. If we use both striding and padding together, and I said what could be the value of the padding? There is a logic to be determined. You can't take a random values for calculating and choosing the padding. Okay, right. How to calculate this p value? Without padding, the image is n by n and the filter f by f when it is convolving, giving the shape n minus f plus 1. This is already we discussed now. Now with padding, what is happening? Just recollect back the example 6 by 6 image. After padding 1 in all directions, I got it into 8 by 8. What does it mean? N plus 2p. The size is becoming, how it is changing? Based on the p value. If I apply 2 padding, I had shown in the torch tensor. You can see that. If the padding value is chosen is 2 in all the directions, you will get n plus 2p is the dimension, right? Okay. So if you apply additional boundary you will get, so the image would become n plus 2p by n plus 2p. When you convolve with the filter of f by f, what is the value you are getting is this one. From this you can get the p value is f minus f 1 by 2. So what could be the padding value for your convolution operation will be determined by your filter. F minus 1 by 2 will be the p value for your convolution operation. Just a simplification of the logic is here. Both the equations we are mapping. So this equation n plus 2p minus f plus 1 is equivalent to the original size n. From this you are getting the p value is f minus 1 by 2. That could be your p value. Good. So once you got it, you are applying striding and padding all together on your input image. Once you did so, what will be the output feature map dimensions? With the input given h1 height, width and dimensions, okay, then what could be the output value? This is the formula, by s plus 1. Okay, this padded input height, I mean to say, what is that padded input? Input is padded, so with added input information is n plus 2p minus f by striding value plus 1. This will give you the dimensions of the output feature map when you apply both the padding and striding on your convolution operation. Remember this formula. And so what is the final last one determined? Number of kernels that you are using. Do this. I am releasing one more exercise. That is another assignment which is on strided convolution along with padding. CNN assignment 5. Yes, assignment is released. You already done with this convolution operation, core convolution operation. Now it is easy for you to do this convolution along with padded striding. See that exercise? Are you able to get it? Assignment 5. Could you please someone confirm? Yes, thank you. CNN assignment 5. In the before exercise you just did the core convolution operation. Here you are going to do strided and padded convolution. So looking at the signature parameters of this method, convolution 2D. Now the function name is convolution 2D. You can observe the change with the previous exercise. There I just gave the signature parameters, input matrix and kernel, because it was a core convolution operation. Now padding is provided, optional, and striding is provided. I told you how to convert a tensor into padded tensor in the prerequisite practice during the tensor operations. So clearly instructions were given. Look at the steps so that you can understand. Now you have the input matrix, kernel, padding and striding values with you. Add the 0 padding to the input matrix first. Already you have the input matrix. Add the 0 padding. Once you do the padding for the image input matrix, now you will get padded input matrix. After getting the padded input matrix, now get the dimensions of the matrix and kernel. So from the difference from the earlier exercise and this one is, before getting the dimensions of the input matrix, first of all apply the padding to the input matrix and get the dimensions. It will be so easy. You don't need to apply that entire formula. That is one way. Following the same formula which is given, that is one way. What is that? N plus 2p. this method will involve one more step. First specifying the dimensions and filling the values for the additional data. All these things are required. The simpler method we already know that. First of all, padding the input matrix which is given and then getting the dimensions. Now you have the volume of the output matrix with the padded input and the striding value. The formula is given with you. Sorry? Fourth assignment done? Error? Okay. Fourth assignment till now 111 graded, 111 members graded. Assignment 4, previous one, 116, 118. Any more submissions? Assignment 4. Already I got 2 submissions and graded. So you need to catch the logic. When you apply, when you are using the striding, how to capture the convolution region. The convolving region of the input matrix will get varied because you are using the striding. So that iteration boundaries to be very clear. The focus should be on capturing the convolving region to perform the element wise multiplication. Here in this case, stride variable is taking the lead. Good, 8 numbers. Any guidance is needed? I am giving a hint, this striding variable is taking the lead in the case of strided convolution. In the earlier logic, when you are getting the region, convolving region, you had iterated through the output dimensions height and width. Am I correct? Now this time, this iteration, there it was step by step iteration. Here this time incremental iteration, thus incremental step, the variable stride is taking that incrementation. That is the difference. Okay, just hold few minutes. Those are so simple exercises. 2 minutes is enough for me to finish off this task. One more core important operation in the convolution neural networks is pooling. We discussed convolution and striding, padding, all these things are discussed. Now the next one important another operation with the convolution neural networks is pooling. What is the need of the pooling? You are getting the feature map after the convolution operations. What this pooling will do is, pooling will downsample the size of the feature map. The meaning of downsampling is reducing the size of the feature map. That is the job of the pooling. So obviously the pooling should be used after the convolution operation. You are having the question of why I need to downsample. Am I correct? So obviously the purpose of the downsampling is to speed up the computations. That is only the basic step. For that, this pooling will help you. What it will do, its job is, whatever the feature map that you are getting by the convolution operation will be downsampled. How it will downsample, how it will reduce that feature map size? By 2 methods. There are 2 different types of pooling. One is the max pooling. If you observe at this matrix, if I use the kernel of size 2 by 2, I don't want the kernel parameters. I just want the size of the kernel. How much region I wanted to cover for doing the pooling operation. This is the kernel pool, pool layer kernel is different from convolution layer kernel. There the parameters will involve in the convolution operations. Here the kernel, there will be no parameters for this kernel in the pooling layer. Only the size is required. How much is the window size which we wanted to perform this pooling operation. If we are assuming 2 by 2 kernel for this pooling operations and I am using striding 2, meaning 2 steps positions. So what it will do, this max pooling operation is, from this region whatever the maximum value, that will be taken. Instead of taking 4 values, I am taking only one value. What is that one? Max value. Meaning that I am doing much focus on more important feature. Of course, I am feeling like that. I am trying to capture more important feature. I wanted to give more attention to the important feature and exempting the rest of this. That is the meaning of taking. So from these 4 values, I am taking only the maximum value, that is 4. This is what is the job of the max pooling layer. There is another pooling layer that is called average pooling, another type of pooling. In that case, instead of taking the maximum value, average of these 4 values will be taken. So what is the average of 5, 2, 1, 6? 6 plus 8, right? What is the average? 6 plus 8, 14 by 4. Am I correct? So average of this value will be taken, that is called average pooling. So for better understanding, more understanding, I will look at this picture. This is the convolution operation results. This is the image, 6 by 6 image convolved with the 3 by 3 filter. You are getting 4 by 4 image, convolution results. From these 4 pixels 8, 9, 8, 2, if I apply the max pooling operation of the filter size 2 by 2, I am getting the values, I am taking only the maximum value from those 4 values. Thus, this max pool layer will downsample the feature maps. So, these max pool layers will be used after the convolution layers only. Right? Do we need of this max pooling layer? Of course. If you wanted to increase the speed of the computation, obviously we will use the max pooling layer, so that more emphasis is there on the certain features of the image. Okay. If I am using, where I supposed to use? After the convolution layer only. And what are the important points here? I said filter size only, not the values. Meaning that there are no parameters and no training in the pooling layer. Okay. But the point is, there is a caution. This pooling is very aggressive. If we are doing this aggressive downsampling by increased filter sizes, 5 by 5, 3 by 3, 7 by 7, likewise, you are going to lose the very fine important information from the data. So don't do like this. Use very small size filters for downsampling in the max pool or the pooling layers, whether it is max or average. So in the max pooling layers, whether it is max or average, we will mention the filter sizes is very simple, 2 by 2. If you look at more advanced architectures like ResNet and all these things, residual networks, those are mostly avoided using the max pooling layers or eliminated totally pooling layers, because they are going to lose the information. Instead of that, they are using the concept of strided convolution, which is already downsampling your feature map. Okay? Right. These are all about the basic operations involved in the convolution neural networks. You done with the 5th assignment also. 6th assignment is so simple, exactly similar to the 5th, only one modification. You can finish off that. That is related to the, okay, let me release that also, and this 10 minutes of time is sufficient for you, you can finish off it. CNN assignment 6, I am releasing. Yes. I opened the CNN assignment 5, I am going to evaluate. CNN assignment 6, which is exactly similar to the fifth assignment, but there we did the strided convolution. Here it is pooling. Almost similar logic. You just have to just focus on it. It's a matter of 2 minutes. Okay, let me check what are the submissions from the fifth assignment. Now you can complete the fifth and sixth assignments in this 15 minutes of time, sufficient. So I can see only 15 submissions from the assignment 5. 16, 25, good number. Assignment 5, 30 submissions, 35, 35 gradings. Finish off both, all the 3, assignment 4, 5, 6. With this we can close today's session.